So now the pattern is ready. Now this D, E and F, D, E in D to E, core boxes produce core halves. You see, these are core boxes. These are not sand casting boxes for your casting. You have to make the cores. So this is a whole casting process for making the core. Core boxes produce core halves which are pasted together later on. The cores will be used to produce the hollow area of the part shown. So you see, if it is a complicated casting, the pattern itself is a huge business in design and making. And then the core is designed, and to produce this core, the core boxes are done. So this is a whole casting process for the core itself. And once it is done, then they are joined together and so on. After your pattern is ready and after your core is ready, then the cope is ready for the sand, right? The cope half of the mold is assembled by securing the cope pattern plate, right? So you have a base. This is just a base, say of a strong wood or something, on which you put the flask. You put the flask and you put the sand inside, and you put the pattern plate. You put the pattern plate for the cope, and then you start putting the sand and you tamping, right? Pressing the sand in the places, and then there will be the mold, the cope part of the mold, right? So this is the outer flask. There will be risers, there will be sprue, and so on. Then you have the G and the H. In G, the flask is rammed with sand and the plate, and inserts are removed, right? So you are showing it from the above side now. You see, it was upside down with the pattern plate. You completely ram it and then you turn it the other way. So you have the sprue and the riser and so on, which has already been cut in the sand. So the cope, after ramming with sand and removing the pattern sprue and risers, those are now. For the sprues and the risers, they have a metal type or wooden type of cones made. The cones are designed, and this will be, right, so that the pattern is there. You tap all the sand. So now it is a solid piece and the pattern is there. And then you take a cone which is made of a metal or something, or of a very high quality wood, and you put that cone to remove the sand for the riser and to remove the sand for the sprue and so on. Okay. Then in the H part, the drag half is produced, right? Because now you again put the flask on the base plate, and this is the pattern plate for the drag part, and then you fill it with sand completely. You fill it with sand completely. Okay. So the drag half is produced in a similar manner. In J, the core is set in place within the drag cavity, right? The core is now set, and so on, right? So these are different. Then here in K, the mold is closed by placing the cope on top of the drag and securing the assembly with pins, right? So the cope is there inside the flask of the cope. The drag is there inside the flask of the drag. All the design inside is now ready, because the pattern plate for the cope and the pattern plate for the drag were used to create the mold cavity in the upper and lower parts of the mold, and the cones and so on were used to make the risers and sprues, and the core was made for the cavity, solid cavity inside. So now it is all ready. So you put them together, and here there are pins on this side and on the other side, and with those pins you join it, so that this is a very smoothly locking cope and drag. After that, after the metal, so right, and once it is there, once it is ready, then you pour what they are not writing, then you pour into the sprue, and you keep on pouring at a very reasonable velocity until it goes through the sprue, through the gating system, through the runners, into the mold cavity completely. Inside the mold cavity, remember, the core is there. The core is there The mold cavity cannot be filled in the core area so that later on a hollow will be there. And after filling the whole mold cavity, it rises in the riser. Once you see that it is, say, risen halfway into the riser, then you stop pouring, because then you know that the metal is completely filled inside. And then you allow it to solidify for the time that has been calculated before. And maybe they have forced cooling with some fans around, they will have designed it, or just normal cooling, And once that cooling time is over, you see, the cooling time, I have told you earlier, has to be very critically designed, whether we will use fans and extra cooling and this and that. Why? Because if the cooling time is too long, then the production rate is slow. But if the cooling time has not been completed, then you open the mold and the cavity has not solidified, right? So it is critical. Once you do all of that, you have done the pouring completely, you have allowed it to solidify completely, then you remove the pins. You take the cope part separately, you take the drag part separately, and just with normal simple hammers and so on, you break the mold. The mold is sand. You break the mold. And after breaking it, this is what remains. The full casting is there. And the sprue and the riser is there. And you have removed the core most probably, right? So after the mold solidifies, the casting is removed from the mold, and because the core was inside, the core is also removed, right? Now this sprue, blind riser, they are cut off or broken off. And if there is any finishing operations, like a small bit of grinding by hand grinding or something, that is done. So all the finishing operations are done. The sprue and risers are cut off and recycled for further casting. It is melted. The casting is cleaned, inspected, heat treated if necessary, and any finishing operations are done like hand grinding and so on. And then the casting is ready for shipment, right? So deliberately, I keep on telling you that if the books are good and if we have selected the drawings and the examples well, then they are full of information. So the casting that they selected here is a complicated casting with bends and angles and so on, and with hole inside. So you have to make the pattern very carefully. You have to make the core very carefully. And we have broken down that big one-page figure into different pages for you so that you could understand it very well. Hopefully, you really understand the steps in sand casting now. Unfortunately, here we haven't been able until now to make foundry as a small lab. In one of my previous universities, there was a large foundry, not a small one, where we had different types of crucible furnaces. Crucibles, I told you, are small types of furnaces where we can make a few kilograms of castings. So there were more than one crucible furnaces. There was a whole area, because it is very critical that the doors, the whole wall one side can be opened, because once casting is done and so on, then you open it completely and a lot of ventilation, otherwise toxic gases and this and that, and the heat amount, and crucible itself means very high melting temperatures of 500, 600, 700, 800 degrees Celsius, and all the equipment to make the patterns, all the equipment to make the cores, all the equipment to make the sand casting itself, including those cones and so on for sprues and risers and so forth, and small baking ovens that if you have made the core, then you have to bake it to make it strong, right? So a foundry, even a small one, is a very large, complicated area. So unfortunately here we do not have it. We have explained this to you, right? And you can see, if you are interested, you just go to the YouTube or anywhere and type casting process, and you can see some videos if you would like to enlarge your knowledge. Additional steps after solidification, we have already talked of them. Trimming means a small machining, removing the core, cleaning the surface, inspection very carefully if everything is right, any repair if required, any heat treatment of the casting if it is to be done, right? So these are all, and in the word trimming, trimming means different types of machining operations, hand grinding, any other thing, and so on. So details of trimming: removal of sprues, runners, risers, parting line flash, fins, chaplets, and any other excess metal from the cast part. For brittle casting alloys, metals that are brittle in nature, and when the cross sections are relatively small, appendages can be broken off. Appendages means anything like this, runner, riser, which is added. Otherwise, right? Otherwise, hammering, shearing, hacksawing, bandsawing, abrasive wheel cutting, or various torch cutting methods are used in this trimming. All these parts have to be removed. So if we just hit it with a hammer and it breaks away very easily, it is okay. But take a small hand saw, take a small band saw, and so on, right? So you can remove sprues, runners, risers, and all of those extra things from the casting. They are all joined to the casting. So you have to remove them either by small hammering and so on, you can, or by, you see, saw cutting, band cutting, this cutting, and so on. Removing the core, right? Because the casting is there, you have cut away all the sprues, this, that, but the core is inside. So if the cores have been used, they must be removed. Most cores are bonded and they often fall out of the casting as the binder deteriorates. Right? Do you understand that binder is some type of chemical that you use, but once the casting is done and because of the heat, the binders are now removed, so the cores just fall out, because inside the core also there is a draft allowance, right? In some cases, they are removed by shaking the casting, either manually or mechanically. In rare cases, cores are removed by chemically dissolving the bonding agent. If the bonding agent was so strong that even after pouring the molten metal at 500, 600, 800 Celsius, it does not dissolve chemical, then you just spray some chemical or something else so that it is dissolved, right? And sometimes solid cores must be hammered or pressed out, right? That by shaking and so on, they don't come out. So from one side, you take a piece of metal, you put it at the end of the core and you hammer, and it goes out from the other end, right? So it depends. It is always a very, so you see, when you are practically doing it, some of these steps you actually see yourself in here. And if you end up in a company where it is actually being done, it was my good luck that in one of my jobs, I have done jobs in different places. In one of my jobs, it was a huge company, huge, unbelievably huge. We used to make the whole sugar mill. One sugar mill contains about 1500, 1600 different parts. And after installation, it will be there in a 1 mile area, 2 kilometer, 3 kilometer area, a sugar mill. So all the parts of the sugar mill were made in our factory. It was a huge general heavy engineering yard. So of course then there was a foundry also. There was a huge machining shop. There was a huge foundry. I was in the design office, but once you do the design steps and so on, then you have to go and coordinate. You know all your manufacturing facilities in the machine shop, in the foundry, in other places. So you have to coordinate and see that this is what we do. And from the design office, we give drawings which go to the foundry. In the foundry, they first go to the pattern making designers and core making designers, and then to the casting designers and so on. So I have physically, though I personally did not work in the foundry, I worked in the design office, but because I was part of a very large firm of general heavy engineering, therefore we used to go there and visit and see the actual operations.